This might be known to some of you, but I'm just going to do it anyway. In the help browser of Pure Data, where almost nobody ever goes, is this section called Data Structures. And the reason no one ever goes there is because I don't tell people to go here because it's experimental and it doesn't really do what you wish it would. I'm just realizing I'm not up to date, but that's all right. I haven't actually got the very latest PD running here. But at any rate, what's going on here is a collection of patches that demonstrates the intended functionality of Pure Data, which is not what Pure Data is. So what Pure Data is right now is a Max alternative. The intention of Pure Data was, first off, let's throw Max away, put Max out of your minds altogether, and start thinking about the following problem. What would be a good way for a computer to represent the stuff that would constitute a computer music score or an electronic music score? Well, we have examples of electronic music scores around. They're all a little bit precious and overstudied, but things by Stockhausen, the first one, the one that people usually look at is Study 2, Studius Phi, which is this thing that's square root of 5 all over the place. And the score looks like a bunch of triangles and trapezoids. Right? It doesn't look like note heads at all. And then you move on to Cantata, which has this sort of fluid and very, what's the right word? Well, fluid, let's just leave it there, way of going back and forth between musical notation in which sometimes more and sometimes less detail is supplied. Like sometimes there's musical time indication, sometimes not, things like that. And other kinds of shapes that describe whatever it might be. And I won't go digging around for copies of these things because everyone who's interested in this sort of thing has looked at them. But you know, the thing where the curves do this kind of stuff, and that means you're supposed to go that kind of nonsense, right? It's all famous, and so I won't drag on through that too much. But at any rate, the idea that you ought to just be able to take a paintbrush to a wall and make something, and then have the computer be able to turn that into the sound that thing represents as an image, is a sort of a fetching one. Or to give you the contrapositive for a second, a lousy way to describe music to a human is using a C-sound score or a cue list or something like that, where what you have is a bunch of time values and a bunch of parameters that are organized into a collection of what are called note cards, and which are instructions for a virtual instrument to pick itself up off the floor and play, and then after a fixed amount of time to die and collapse back to the floor. Right? So that's the C-sound model. And in fact, you would say, well, actually, C-sound is old. Things like Max are more advanced than that. And then if you look at what happens when you try to make a score in Max, what are the things that you get? Well, you get call, and you get cue list and stuff like that. And if you look at what goes in there, it's lists of junk, exactly the same as a C-sound score. Right? And well, the truth is that for certain kinds of applications, that's precisely the kind of representation that you would want. But it falls far short of being able to describe what you have in your head when you try to think of a musical sound or a musical behavior of some kind. So what would be a good language or a good data representation for freely representing musical ideas in a computer environment? Why is that? Let's see. That's not the right question to ask. I'm trying to figure out what the next question should be. Next question should be, well, let me just not ask questions, but just go a little bit further. Since no two people who do computer music or electronic music end up using precisely the same techniques or precisely the same configuration of objects or whatever you might want to call it, it should be the case that whatever you draw should be interpretable in a way that you specify. And the way that works in the old electronic music scores is the composer writes a few pages of prose at the beginning of the score saying, well, this means this and this means that and so on, and then you read that, and then you go read the score, and then you have then you can go realize the piece. And what would be the equivalent in computer land? Well, the equivalent would be some kind of functionality that sits behind the graphical representation that that allows you to specify how those things should be interpreted. So things like color or screen location or size or shape or whatnot should be things that the underlying computer music system ought to be able to inspect and turn into sound. And if you did that right, then you might be able to do the opposite thing too, or the reverse as well, which would be to take a sound and analyze it, and take the analysis, somehow gather the analysis up into a discrete collection of objects and make those objects be things that show up on a screen in such a way that when you hit go, the thing would reconstruct the sound, but you could move the objects around and change the sound. Or paste it into some other thing, combine aspects of some sounds, or make an assemblage that consists of aspects of a whole bunch of sounds that changes in time in some way that you would describe. And what would the functionality be? Well, the easiest way that I knew of to make sound come out of a thing was to have something like max. So I ended up just going ahead and doing the OSC tilde again, and the times tilde again, and the del right tilde again, and so on like that. And I pretty soon ended up with a max clone that basically was supposed to be kind of the minor, sort of get this done aspect of this project, which really was all about making these electronic scores. So the reason pure data is called pure data is because what I thought was what you should really be doing as a computer musician is arranging data on a screen, which is your computer music score. And the functionality behind it was not going to be terribly interesting. It was just going to be some stupid max clone. Well, what ended up happening historically is that the stupid max clone turns out to be more useful than the interesting part of pure data. Because the stupid max clone, well, you've seen me use it a lot, and some of you have used it a lot. It turns out to be pretty useful. And this thing is not useful, even though it's what really is what pure data is all about. And that is it. And the reason I'm presenting this in a creative coding context is because this is a thing. This is a talk about stuff that just doesn't work yet, that you should think about because it's not happening yet. And it would be interesting to analyze why it's not happening and go back and think again and invent something cool and solve some problem that hasn't been solved yet, which would be an interesting, doctoral dissertation or life's work or something like that. Right. So here's what I decided to try to do. Yeah. Sorry. One other bit of preamble is this. Of course, such a score shouldn't just specify how you would put together a tape piece, but should also be allowed or be usable in a context where you would use it in making interactive electronic music, which is, of course, the stuff that really interests me. And there, what you want to be able to specify is not just a sequence of events, but a bunch of behaviors which, at the very minimum, would be able to describe a sequence of events, but should in some way be something larger than that. In other words, the events might be potentialities instead of just events, or they might be behaviors, which also might depend on input as well as simply generating output. And again, that ought to be possible as long as you are specifying the functionality that underlies whatever it is. You as the composer, I mean, are specifying the functionality. As long as that's true, then this thing wouldn't just be good for making electronic scores that make fixed media pieces, but should be also good for making interactive pieces. And yeah, I won't belabor that point, but there's a lot of interesting stuff. There's a lot of interesting stuff to say then about in interactive electronic music, what really is the relationship between what is pre-stored and what happens live. And that, I think, is something that should remain technologically open because it's a question that's actually musically interesting. And therefore, different pieces or different approaches might give you radically different ways of interpreting how the pre-existing thing which you think of as the score of the piece of music really should interact with what happens live. That needn't be what it was in the 19th century at all. And that should be left open. So what I came up with, and again, I'm going to just say this doesn't, this works, but it doesn't actually do anything useful. Or it doesn't do anything very useful. It does something that is occasionally somewhat slightly useful. So here's the deal. You get windows in which you can put stuff, and this is just a regular old pure data window. In fact, I can put I can put objects in here too. There's nothing special about the window except these objects that are in it, which are things that that are data. What are they? Well, one way I could answer that is I could open one of them by getting its properties, and you can see what's in here. The numbers in that are 246, 137, minus 2900. That is the x and y position, the altitude, and the color, if you like. But why those particular things? Because of stuff I've done elsewhere. But let's get out of here. So for instance, if what I can do with this triangle is, of course, move it around, and I can also change its altitude, but nothing else about it is mutable. Right? And so now, in principle, you could then make this thing be, have a sound. You could associate a sound with this thing, and then you'd be making these triangles, and the color and the altitude and the position would affect how the thing sounded. Right? And now, what did you do? What did you do in order to make that happen? Well, you made what I call a template, which is the same thing roughly as a data structure in C, or a, well, I'll just call it that for now. So you say struct, and then you say what the structure is going to be. It has a name, and I called it template 1. I'm not exactly sure what the word template means, and I don't think I'm using it right in calling this thing a template. But the meaning of this thing is that anytime I make something which belongs to class template 1, it will have the following, what do you call them, instance variables. Sorry, this is object-oriented language. The instance variables are x, y, z, and q, and they are all floating point numbers. Right. So this is a data structure with 4 slots in it, or if you like, it's an object with 4 instance variables, but they're the same thing, actually. To say that they're different is just making complicated talk. And what do x and y and z and q mean? Well, nothing, because all I did was say what their names were going to be and what they were, or sorry, what type they had. And what they mean depends on what you do with them. And the 2 things that you can do with them are you can draw them, or you can get them in the context of a patch, or set them. So drawing them, you do in the window that defines the structure. So in that window, everything that you do in that window modifies this structure, just because that's not good programming practice, or that's just sort of a thing I did. So someone could think about this better. And so how you draw it is you say, give me a filled polygon and make the interior color be 244, the stroke color, what do you call that? The color of the border be Q, which is a variable, the line width to be 5, and then the points of the thing are going to be 0, 0, 0, 20, no, sorry, 0, I forget what that is. Then the points are, oh no, that's not, no, I said it right the first time. 0, 0, 20, Z, which is the point whose x-axis is 20 and y-axis is Z, and then the point 40, 0, which is go back down to 0 and over another 20 pixels. Pixels, okay, we'll get into that if you care. Maybe you should be able to change that, and you can, sort of, but it's not very good. So what I accomplished by making 2 of those things be variable, that's to say the color of the border, which is Q, and the altitude, which is Z, is that now I can have different values of Q and Z for different ones of these, but all the values that I gave as constants are all the same for each one. So for instance, if I now just change the color of the interior, let's make it be green. Right? Oh, and here we get into the first really unfortunate thing that happened. Actually, I'm not sure if this is unfortunate or not. Why is 90 green? Okay, RGB. How are you going to deal with the fact that you have to specify 3 variables to give you a color?
Multiplex it.
Yeah,
That's what you did.
why not? So I use what I call 999 colors space, which is the hundreds is blue. No, the hundreds is red. The tens is green, and the units are blue. And that gives you 10 possible values of each one for 1,000 possible colors. Which is, why would you do that? Well, what else do you want to do? You could make 3 separate variables, but then I would have 6 variables here just to specify the goddamn color of this thing, which would be far too heavy. Because if you think about how you're going to use color, if you use it, it's most likely going to get used as an index as opposed to a continuous value. In other words, usually when people use color, when they try to represent data, they use it like you do in a graph, like the red points mean this and the blue points mean that. And in that case, what you want really is a palette of a fixed set of colors that you're going to use. At which point, why don't we just make it be a simple one number representation of what the color is? And there could have been a color map, but why make a color map when you don't have to, when you can just do something stupid like 999 format? And it works. It's never felt limiting to me, so I don't think it's really a problem.
Can the arguments that are variable accept like real-time continuous
Yes.
information?
So for instance, Q is a variable, so that means that the outer color, the red and blue, that is changeable continuously. So for instance, now I'm going to show you why this is really not useful. Let's go change the color of one of these puppies. So I'm going to actually make myself a separate sub-window to do this in. Okay, so first off, we got to get ourselves a pointer to one of these things. How are you going to do that? Well, okay, let's go get it. So it's in the window called data. So I have to make a pointer object. And I'm going to say, please let us traverse, which just means go find or go jump to the window which is called PD data. Hey, data. And now which one are we talking about? Data. You know what? Let's not do this. Let's do something else. I'll do this later. First I'll do this. Let's use the output of this structure. Okay. Let's see what happens when we click on one of these things. You see where this is going probably, right? And now I'm going to click on this sucker. And it's going to say, hey, there's a pointer, and I don't know what 114 represents, but anyway. What are those numbers? Well, we don't care what those numbers. Oh, I guess it's pointer. I don't know. Anyway. Oh, so what came out was the selector click and then a pointer. So let's go get it now. So we're going to unpack. And oh no, wait. I'm going to route click. And then we're going to unpack pointer. And then 0. Let's get this out of here. And then that gives us a pointer, which I'm going to store. And a pointer object, which is like a float object, except it stores a pointer. And now I'm going to click on one of these puppies. And now it's in this pointer. Now what did that do for me? That didn't do anything interesting. Let's do something like set. So set takes, it wants to know what kind of template we're talking about. Template 1. And I'm going to set template 1's color, which is Q in this data structure. Now the pointer, I think, goes here. This is stupid. I didn't have to do that. I could do this. And then I'm going to put a number box here. And if this works, I'll be able to click here and then scroll on the number box. Look at that. And now I'm changing the color of that puppy in 999 format. Okay. Isn't that awful? That's really bad. You should. That took a lot of messing around, and I actually know what I'm doing, or at least I know as well as anyone knows what I'm doing here. So the basic deal is you could click on one of these things in order to specify it, but of course you're not really gonna. You don't want to have a score where you have to click on all the events in order to get them, right? So really what you want to have is some programmatic way of getting to them, right? So you can do that too. I was doing this because I didn't know which of these was which, and so how are you going to find out which is which? Well, you click on it, right? Or you could do this. You could say, well, okay, I'm not jumping ahead of myself. There could be another basis on which you figure out which one you're talking about. Like, for instance, you could have a field of the thing be which one you are, or you could actually know how many in the list of things it was. So let's pretend we know that. So now I'm going to go back and get my window that doesn't have anything going on. And I'm going to say now to the same pointer object, why don't we just start on the PD data window, and let's just say next. And then I think we have to say, I'm not sure, but we might have to say, I don't know, probably we do bang. to make the thing output itself. And now I can go back and say, yeah, get Q. Let's look at this. Let's separate this out. So first off, traverse PD data. What that will do is that'll set the pointer to the head of the list. And then if I want to, I can send it a message that says next. And I think I can't remember if I have to bang it or not, so let's just not see what happens. And now I'll put a number box here, and then maybe I say start, next, next, next. No, got wrong template. PD template 1. Oh, I have to say get template 1, Q, traverse next. Ah, there we go, see? So now I'm reading out the values of Q sequentially. Go to the beginning, and then first one is 9, which is blue. Second one was 900, which is red. Second one was third one was 900, and the last one is 287, which is that number I just dragged this thing to, which should be this number here, yeah. Right, so here we already have something like an animated draw program, like, you know, I don't know what the modern draw programs are, Illustrator or something like that. So it's a cruddy little Illustrator, but on the other hand, it's an animated Illustrator, which means it's an Illustrator that has functionality behind it that lets you get a hold of all the handles on the thing that you're making and do stuff to them, like either change them or just get them and use them to make music with. All right? Now, why is this a stupid score language? Actually, let me show you what you can get out of it as a score language, and then you can tell me why it's stupid just as well as I can tell you. So I'm going to close this. Oh, are there questions about what I've done so far? Has this filled anyone with a burning desire to actually use this yet? Okay. All right. So let me just no. I'm going to jump forward a little bit. Hello. Why am I here? Oh, I see. I'm getting I was here in the browser land, yeah. So let's go get something. Sequencer. So here's one that actually has a little score. Here the horizontal axis is going to be interpreted as time. By the way, there's no assumption that the horizontal axis should be time, right? Because in fact these are just a bunch of objects on the screen. But there are features that would help you use the horizontal axis as time if that's what you happen to want to do, which turns out to be well over half the time that's how you want it. At least in my experience. I mean, sometimes you would just want a heap of stuff that doesn't have any particular order, in which case you wouldn't. So in this example, horizontal axis is time. The black shapes are dynamics in kind of lousy but pseudo-musical format. In other words, fatter means louder and skinnier means quieter. And it's a logarithmic scale, which means if you slip and make the thing a little bit too fat, the thing will be 200 decibels and it will be too loud. That needs fixing. Or rather, that needs to be thinking. And then the other colored things are the traces that describe the pitch and bandwidth. So this is a score that this is a score that's in imitation of a piece by Joji Wasa called "Toward the Midnight Sun," which has a graphical representation in which there are traces whose fatness is bandwidth and whose up and down is pitch, center pitch. Although they're not, and it's a noise. These are noisy sounds. Although they are not just a second order filter, they are instead, it's much more interesting than that. He made 3 narrow band traces, one at the top, one at the middle, and one at the bottom, so that it doesn't just sort of spill all over the place, but so that even if you give it a large bandwidth, it kind of stops at the top and bottom. But you wouldn't think that would sound terribly good, but it actually works much better than you would think. And it was doable in the 1960s when he was doing this piece. So that was cool. Anyway, so now you can imagine what this thing sounds like. And what I'll do is I'll slow it way down, and then just play it for you. And I'll try to point to the stuff. Actually, before that, let me just quickly show you. These two things are part of the same object. as are these two things. These two things meaning the black part and the red part. Here, this black part, you can't really tell, goes with this green thing. So this thing is that size, which is kind of ugly because then it can get on top of the other stuff and then you can't click through it to get to the other stuff and so on like that. So there are various problems of collisions here that probably needed to get thought of before I went out and made this thing like this. So the events are then this thing and then this humongous thing and then this. So this is a thing with narrow bandwidth and a fixed pitch. This is a thing with broad bandwidth and a descending pitch. But this one is well, that shape, and this thing has actually 3 little bursts in it, right? This thing is a percussive sound. It comes on loud and then goes out quietly, and it doesn't have any pitch English in it at all. And similarly, this is the opposite of a percussion sound, so on like that. So now I'll just point to these things as it plays. I don't know how loud to make it. Let's see. Let's hope for the best here. So there's that. There's this thing. That's that. Now we're here. Now this thing is going. That's these things. And there's the percussive sound, right? And then if you play that as at its intended tempo, which you can now follow, you'll hear it. Ta-da. Okay, it's a thing. It's not. What's wrong with it? Well, the first thing that's wrong with it is this. You cannot look. There isn't a bunch of horizontal lines in sets of 5 that tell you what the pitches are. Instead, the pitches are actually continuously variable by position on the screen, which is, of course, much freer than putting things on staves because you have an immediate way of describing microtonality. But on the other hand, it's wrong because there's no way in hell you could look at this picture and figure out what pitch this is going to be right here. It's not going to work. And even if you put a grid down, which I haven't done, but if you had, which you could, it would still be kind of a bother because the just noticeable difference in pitch is like 3 cents. So you would need a 1 in 3,000 resolution to be able to maintain a pitch down to just noticeable difference, which is eating your entire, well, is eating more than this entire screen. This is 768 pixels, so there isn't enough resolution here to represent a pitch graphically. Oops. No good. Well, what would you do? Well, okay, then you can think of lots and lots of possible workarounds, none of which is actually usable that I've been able to find anyway. In fact, as far as I can tell, if you want to represent pitch graphically, the only way you can do it is symbolically. By which I mean, just write the number. That works just great. But you know who did that? Barry Verco did that, or Max Matthews even. You used to be able to write the number back in 1957. So we've got nowhere with pitch, right? We're nowhere better than we are in 1957. Or you could make it symbolic like A flat plus 37 cents. That I claim is a symbolic representation as opposed to a pictorial representation. Right? I mean, okay, you could use different meanings of the word symbolic, but that's, you would type such a thing out. You wouldn't draw a picture to show that value. You would just type the value because that's the way you do it. Right? So in fact, what you really want to be able to do is just put numbers down. And that works up to a point. And the point where that stops working is when you want things to be changing continuously in time, where you want to just draw a curve, please, right? So somehow you need to be able to combine just writing the number down with describing graphically how you want the thing to move, or something like that. And then the something like that pretty soon becomes intractable. And I don't actually know what composers do about this kind of a problem. What I do about problems like that is I just scribble something on a piece of paper and I pick up my guitar and play it, or just sing it, because that turns out to be a much better way of describing the evolution of something in time than even making curves and adorning it with numbers would be. So in fact, even though people like Stockhausen and Joji Wasa and so on, found it useful in the score to make these curves that represent changing pitches. When you actually ask a violinist, say, to interpret this thing, which is a note with a little curve showing the pitch deviation afterward, they don't actually do anything that follows in any quantitative way what you had drawn on that piece of paper. So the whole idea that you should then be able to have the computer turn that into sound is a fallacy or a lost cause, one or the other. So that is a thing that I don't know what to say about, except, well, I'll say something else about it, which is this. Why don't you, instead of doing this, do this? Do I want to say any more about this? No. Oh. I'm going to keep this out because I might go back to it. Or I hope I will go back to it. So let's get the browser back out. And now I'm going to show you another thing, which is, well, one thing that you could do is just don't expect to be able to draw something and have it be sound, but instead derive all these things from human gestures in some way. So this is actually a human gesture captured in that same kind of format. And now I know that these curves actually mean something because, although I can't see what they mean by looking at them, I know what they mean because I know what the sound is. Right? And the sound is, you can probably figure out just by looking at it what kind of a thing this is. It's speech. And I can maybe play this, I'm not sure. Oh wait, click here first. Turn this on and say...
Continue with soft and relaxing.
Yeah, there we go. So this is now a...
Continue with soft and relaxing.
That is a sinusoidal bank. A bank of sinusoids is playing this bunch of up to, I think, 50 traces. Right? And to prove that it's not actually a sampled voice, I can do this. So we're here now. There's the T. There's T. There's X. And there's Ing. Right? Cool. Right? Well, that was just a sinusoidal decomposition and resynthesis, right? But it was actually resynthesized from this analysis. So first off, of course, I could take another sound and put it in here. Or I could take various sounds and put them in here on top of each other and find some way of melding them, which might be an interesting tool for describing morphs. So let's see how far we can get with editing this thing. Okay. And here's where it's going to fall down again. So first off, let's make a little room. Ooh, yeah, it hates itself. Yeah. Oh, what are these things doing there? I don't know.
Is the code behind each one of those little boxes that we just saw that contain those lines, is that similar to the code that stores the array data in arrays?
Yeah, it's the same thing. So these actually are PD arrays. So in fact, you can use these as waveforms for an oscillator if you want to, which might be interesting. Or you can grab waveforms out of a recording and put them up here and use them as pitch trace. I don't know what you could do, right? Stuff like that. Let's mess with him. So here's continuous. So let's first off let's take his tongue out and let's strangle him. Never liked this guy anyway. Right? Something like that. And then I don't know. Let's grab this. Well, I don't know what to do. I don't know how to select these things as a group. Maybe I do actually. Let's select these things. Whoops, no, not that one. Select these things, but not these things. We're sort of getting there. Not that necessarily. And do this to it. I don't know, right? Now let's save that. Oh, save doesn't mean anything in this context. Now let's listen to it and see what we get. Let's play him at half speed.
Continuous soft and relaxing.
Right? Yeah, okay, not so bad. And you know, let's really give him. I don't know what this will do. Oh, actually, let's well, you get the idea. Let's take some of this out. Let's throw some of this in.
Continuous soft Softly relaxing.
Right? Okay. It's not music yet. It is interesting in that we are in some way reaching into a sound and doing something with it. Oh yeah, let's do it. Another thing that's useful is let's do the Jean-Claude Risset and play with the fusion characteristics of this, which we could do by taking these things and progressively delaying them. Let's see, shift. Where's the shift key on this side? I don't see it. Okay. Ding, and then boing. All right, I'm making a nice arpeggio here. And this will fix it so that these partials don't fuse anymore, I think. Not that sure what'll happen actually. Okay. Let's let it be. Okay, so ignore or listen for this part now. Right?
Relaxing.
Okay, we got stuff we can play with. And if you were in earcom in the 1970s, late 70s, this would just be golden, right? In the here and now, I'm not sure what this is worth, but it's a thing. What's wrong with it? Well, first thing that's wrong with it is, okay, and now I'm going to get this and the other thing side by side so we can start talking comparatively, right? So this one is purely synthetic in the sense that I drew it. This one is derived from an analysis, so this is a sort of an analysis resynthesis kind of situation. First off, there's quite a gulf between what those two things do. Here, I actually got, or I could have, access to the exact pitch that I originally had. But on the other hand, when I start linking with it, then I got the ability to change it, but I don't really have the ability to control in any real way what I'm changing it to. So as soon as you start editing it, you sort of lose the fact that it's taken from an analysis and therefore is actually accurate. And then you're in the situation which you're in here, which is that you're just sort of messing around without really being able to control things to a musical degree of precision. Another thing is, notice here I was able to get the loudness represented. Here, you can't actually see the loudness of these traces. The loudnesses are changing continuously in time, and that's how the vowel sounds are being formed, is the changing balance of the harmonics of the voice. And you can't even see it, much less manipulate it. And I could make you see it by making the traces look like this, but then this would just turn into a black blob. So there's actually, by the time you've represented enough data to actually be a representation, you've taken yourself, you've gotten the screen so black that you can't edit the thing anymore. Yeah.
Are they displayed in any way? Is it just the? I mean,
No.
you're not using color.
No, and
at all to.
actually, I would like to try using color, although I don't know if you'd really be able to see it.
Well, like in Spear, which is
Yeah.
assisted, that would be the
The grayscale. or
grayscale.
something
I mean,
like that.
here you've not got that many grays because
You don't have that many
you
grays
have
because you're in.
colors and types of.
Well, yeah, it's because when I started this, it was through a color map.
Yeah.
And it was 8-bit color,
Yeah.
so you couldn't actually get continuous grayscale.
Yeah.
But even if you could, so you would show grayscale, then what would you do to edit it?
Yeah.
It's not clear because it's not clear what it means to click on a color and move it.
Mm.
No, but you could do conditional selection, for instance. If you had like different nuances, selecting by, the shades of gray, these 50 shades
Yeah.
of gray there, or
You
some
can
kind
have
of
a
darker zone, or
paintbrush that darkens. So
yeah, it's something kind of like
make
all
it
the
lighter,
graphic,
make it quieter.
the Photoshop,
Yeah.
Yeah.
the Photoshopping approach to graphs.
Yeah, that might work.
Maybe.
The truth is that the version of TK that existed when I started, I don't know if this has changed. This particular graphical object doesn't actually allow you to change the color, to have anything other than a constant color.
Yep.
And so I didn't have any way to do it.
Yeah.
In fact, if I redid this in a more modern graphical toolkit, then I would be able to at least try that and see. And I have a feeling it would be okay. It would be better than what it is now, but it wouldn't still be what you really want. Or you could do like in here and have a separate trace for the amplitude that would go up and down maybe. But then you would have a horrible problem because you would see all these traces and some of them would be amplitudes and some of them frequencies, and you wouldn't be able. You'd be able to tell which was which. Perhaps you could distinguish them, but you wouldn't be able to tell which was associated with which. And then you would just have a mess. So it actually is already kind of beyond what you can represent graphically in a way that, or at least as far as I know, I don't know if you can really get this to where it represents what you're hearing graphically to enough precision that you can really change things the way you want to be changed. Yeah. Another stupid thing is this. I moved all these things up approximately in parallel. This is a logarithmic frequency scale, like pitch. But of course, these things really should probably be locked into a harmonic relationship. But it's unclear what that means in this context because you don't really know, without labeling it somehow, which trace is stuck with which other trace, or which trace should be in what harmonic relationship with which other trace. And then all of a sudden you have to have more structure. And there's already enough structure here that it's a pain to program this. So imagine using the get and set business here that you saw there. I got one number successfully and it took me 5 minutes of messing around to do. Well, imagine what it takes you to actually make a little automaton that gets these things and throws them into a bank of oscillators. It's already kind of painful. And then if you wanted to actually associate these things with each other and have ways of tying these things together programmatically, then it would just, I mean, you could make PD do it, but the point to PD is not to do stuff like that, because that's a decision about how you want to interpret things. Therefore, it should be the composer that does that, but then it's putting too much on the composer. So I don't know what the solution to that is at all. In other words, what we have here is something that, for what you get out of it, takes far more work than is worth it to get the result that you're getting for most people in most situations. The one thing that this was remarkably successful about was generating the figures for my book. So if you download my book, you'll see these figures are in some weird format. They're actually pure data patches, and that was a good decision at the time because there wasn't at that time, as far as I know, an open standard for representing drawing instructions. There were bitmaps and photograph, what do we say, image representations, but there were not representations such as PostScript that were associated with a draw program. So you could draw something and then dump it to PostScript, but then you couldn't pick it up and draw it again. Now we have SVG, which is an interchange format that allows you to draw stuff, save it, recall it, safely 10 years later change it. But that did not exist at the epoch when I was making this book. And therefore, this was actually a good solution for me for making the book, because I knew that it would never change, because I'm determined to keep this thing back compatible. But that's that's a horrible failure when your score format turns out to make the figures for your book, but it turns out to be useless for describing musical scores in the end. Let's see, what else failed? Well, that's maybe enough failure. I'm not sure that I think those are the worst aspects of it. So, although I really should show you how much of a pain in the ass it really is to turn this into sound. So let's go back to the sequencer here, and I'll show you how we're actually getting through it, if I can find it. Synthesis. So first off, there isn't any good news. So here's a nice loop that traverses the same thing. Okay, we're going to find the thing called PD data, and we're going to just ask it for the next one, which is to say it's the first one, because there's actually a fake place for the head of the list that doesn't have anything on it for weird reasons that I can't explain right now. So let's get the first thing in the thing, and it's a pointer. And anyway, let's do a trigger thing, so we will get the voice number, which is actually the color. And then we'll pack that with the pointer itself again, and then we will route that to all the colors that I use. So here are all the primary and secondary colors, which are the colors that I used here. So these colors are just labels for voice numbers, which is kind of stupid. And then here are the voices. Each one of these then gets one of these pointers and plays it. But playing it, of course, means first wait for it to be time to play it, and then play it. And by the way, when you do start playing it, spit out a pointer to the next one, which arrives here. So these things have to now send immediately a next event as soon as they start playing, so that this thing can then look at the next one and see what the wait is for it, so that it can start that delay. So the first thing in voice has to be, ooh, that was a bad thing.
Okay.
First thing in voice has to be a delay. We have to get the, oh, magnet, okay, good. We have to get the amount we're going to delay it by before we can do anything else. So abstraction called data start, these are abstractions here. And the abstraction called data start is going to do the delaying. There's a delay object. So we get a pointer in here and we get the X and Y value. We tell everybody what the time of last event is and receive it back. Yeah, because there are a bunch of these things and we want to share that among all of them, so that's kind of a global variable. And then we will subtract the time of the next event times the previous time of the next event. And that will be a delay, which would, tempo dependent, so we multiply it by a multiplier, and that's what goes into the delay. And then out comes the pointer again, pointer that we saved, and then we're ready to start playing it. And playing it consists of running through the both shapes, the pitch shape and the amplitude shape. And that's done by the data array abstraction, which gets the thing, and, well, I won't go into this, but it basically goes through the array of breakpoints here and sequences them in time, and then spits out their coordinates in such a way that line tilde objects later on can deal with it. Right? So you had to have 2 copies of that thing. And then you have to have, and then
Sorry to interrupt.
Yeah.
Is time dealt with as a pixel per unit of time? For instance, times your multiplier for the overall tempo.
Yeah,
Basically.
you can basically ask for the pixel to have any numeric value you want, but by default it's 1. But it is by pixel because it's by the values themselves are floating points, so they can be sub pixel. But of course, to graph them, you have to then decide what pixel to start them on, and that is just the pixel per x times the x value. So it's proportional to the pixel. And then here's my noise going through the 3 filters. These things are computed from the pitch array and so on. So that's all you had. The synthesis part was easy or direct, whereas the getting through the data part was just miserable. And this is for an almost artificially simple example.
And short.
And short. Oh, it didn't have to be short, but it wasn't going to get any more complicated. It wasn't going to get any more expressive. Yeah. So go think about that and.
Anything that worked well. You just presented us a list of things that didn't work well in your.
Yeah. Well, I'm actually always interested in what's not working because that's where you have an opportunity to do something cool, right?
Okay.
If someone else has already got something that's cool, then it's not interesting to me as a researcher because then it's already working. Yeah.
I mean, what's the last time that you kind of because these patches have been in PD for quite some time.
Yeah.
I
I haven't touched this in like 15 years because I've been
think-
stuck right here.
Okay, so I think I saw this. You talk about this kind of aspects of PD in Basel.
Oh my.
Which was 2004, 5.
Okay, it might have been almost exactly in the same state as it is now.
So yeah, but
This
it's
has been
still-
sitting here for a long time.
There's still something in your mind that sort of brings you back to thinking about it every so often, but you
Oh yeah.
there's no solutions have presented themselves.
No.
Is that- Okay.
Basically, well, I don't actually put something down until I'm pretty confident about it.
Okay.
And so I've had various ideas like, oh, you could do this and do that and so on, but I haven't found a combination where it's powerful enough that I can see that when I do it, suddenly the thing will actually make it to usability. Yeah.
It's going to sound like a bit of an odd question, but rolling back to the beginning of this bit. I wonder whether the questions right at the beginning are right, or whether they're clear enough in what the point of this is in the first place. So in other words, what are you trying to get out of graphical representation in the first place? So are we interested in seeing the graphical representation and somehow having a sense of what it sounds like? Or are we interested in doing it so that we can play with it and see what comes out? Or are we interested in giving it to other people to realise it? They're not. Are they all the same thing? Because they sort of are in an ordinary score, but they're not, because you have to know the code anyway,
Right.
the language of the score. So I'm sort of trying to roll it back to. And this is interesting, but I'm trying to work out quite where it would. You know, in order to understand, in order to get something that works, as you say, or is good. I'm not quite sure what the question is in the first place.
Well, it might be fair to say that success would be making that question itself clearly definable. In other words, if you had a system that you could use in order to visualize, or could use, or maybe could set up differently in such a way that you would specify more than visualizing, or could set up in a different way in such a way that you would actually be representing a score that has a human repeatable thing. Maybe there are enough common aspects to a system that would permit those things, even if the actual solutions that were aimed at those particular kinds of utilization were different from each other. That would be one possible answer. Another is that there might actually be a continuum between all those aspects of things. Or not even in a continuum, but there might be ways in which aspects of the thing would be for human reading, but other aspects of it would be for analysis or something like that. In which case, you would try to avoid the question as long as you could, until it came back and actually wouldn't budge out of your eyesight, so that then you had to confront it. So in a way, what I was doing, I think, was trying to leave all those options open as long as possible. And that might actually have been a mistake, because in fact, I might have just done better by deciding I was all about this or all about that.
I suppose that's kind of back to my question, I think.
Yeah, right. So I think the answer is I don't have any answer, and it's unclear to me whether you would have to answer that question before you could make a good general scoring system, or whether you could get away with putting that one under the rug for a while. Right?
That goes back to your statement of the first talk, where that we talked about in my office, where you tend, it's your mathematician background, I think, you tend to find a generalized answer to a wide set of questions, where maybe some of your users of PD will jump on anecdotal local answers to very strongly defined hypotheses. So they will, instead of trying to go for a generalized answer, you will say, actually, I need that pitch. I think of, for instance, how Casper Toplitz notates for his laptop ensemble, where, or even his instrumental music, where he doesn't care about the pitch, he wants the beating. So he started to find ways of notating the rhythm of the beating, but he doesn't really care about the rhythm itself, he cares about the certain density. So he found for each piece a specialized variation on the notation set.
Yeah.
Which, because you think more in terms of a computer scientist when you design from the coding perspective, let's say, you try to find a more encompassing solution, which is all to your honor, because it allows a lot of the other people to actually use your tools and go places. But
Yeah, the idea should be, as a composer, you could customize this thing on a piece-by-piece basis. And in any given situation, actually use whatever was the strongest way of describing what it was that you were trying to describe.
But, I mean, I wonder if because part of what your criticism of the system, because I mean, both examples that you showed, they both do stuff.
Yeah.
And they work.
Yeah.
And we can kind of understand them. So, and yes, they have the problems that you described, but I wonder if some of the issues are around this idea of trying to keep everything so abstract. So you're so far away from specific problems, and I don't know, there are a number of other examples in computer music where these kind of attempts to keep things, the more generalizable it is, the more the person you hand it over to has to do work.
Yes.
So, this is the FCM example where the adoption was very low because everyone was like, and then also it's complex. People often pick up on one set of functionality and then you have a whole bunch of people replicating the same work, which is like the worst case scenario. And I think that was part of their idea in making Mubu, was like, oh, here's the bits that everybody actually wants from this, sort of packaged up. And you have Mubu and you can't do anything, you have limited things that you can do with it, so you have that kind of trade-off. But it seems to me that, or I suppose, I mean, maybe a way of keeping some of the flexibility is to offer a set of tools, but by doing, rather that are more biased, but that have several biases rather than one bias. But it seems like it's quite hard to keep everything so abstract. I mean, here you're almost, you have the word pointer on the screen, you're almost dealing with things at the level of C abstraction that you would have at, on the level of your kind of C code. Like,
Yeah, yeah.
Here's my reference to this thing, which could mean anything.
Right. Yeah.
And
That's
yeah.
right.
So I wonder, because it seems like at the same time you said, at least half the time the y-axis is going to be time.
Excellent.
And yet there's
yeah.
nothing built into that. So
Right.
what you ended up doing here is building all
Yeah,
the
having to
time
make that happen in the objects.
back
which is-
in. So
Right.
it seems like maybe saying, okay, well there'll be at least one option where x is time.
Mhm.
Like,
Yeah,
so,
that one
and
seems
then maybe there'll be
fundamental
other
enough that-
options where it won't be time, but
And a good solution, a good example of such an hybrid, they're very hard to find, but the Bach library is a good example. Have you come across the Bach library
yeah.
from Mac?
Mhm.
So it's kind of got a very deep level of openness should you want to go there.
Mhm.
Yet it's quite biased in terms of a subset of tasks it's trying to tackle,
Mhm.
I think. No? Do you agree?
I haven't
Yes,
used it
I
much.
find-
I
yeah.
don't know.
I find that it's very it's very CAO.
Yes, definitely.
I don't know how to say what that is in English.
Computer-assisted
If
instrumental.
you were at EarCom and wanted to make a composer's assistant, that's what you would do. Is
I
you would
mean-
make something that allowed you to, transpose into some
Abstract.
just transformations of sequences of pitches, right?
But that's, to make that happen, they did, sort of alarming amounts of work under that. They're one of the
Yeah.
only people passing around, I don't know if they're still doing it, their own data type in Max. So it's not a float, it's not a
Yeah.
symbol,
It's
it's
a pointer.
It's an LLL,
Yeah, right.
which is their custom data type.
Yeah.
So yeah, to me it seems like in all these situations, someone has to do like a whole load of, someone has to do spade work, and you can move it around.
Yeah, but for instance, like answering your question about multiple modes of representation of pitch, if you start to dwell into Bach, you will find that you can use score, but then you can attach a continuous controller to it and draw freely and decide the boundaries of that. So you can have abstracted or a macro grid of pitch and suddenly go into the detail that could be, could be a full semitone for the full window, and then you can have those cohabitating. And
Yeah, so that's what we call pitch bend in MIDI language.
yes, exactly, like pitch bend, exactly. But you can have they do that for timbral, like controlling
Timbre
electronics, timbral band, exactly, or
Yeah.
amplitude band. So
But yeah, again, if each person who gets PD has to decide their pitch representation again, that's a kind of replication of what. So if there are good solutions, it would make sense to have 10 options for representing pitch that privilege different kinds of behaviour, which gives you a direct way into something that
Yeah.
for PD2,
Yeah.
no.
Yeah. The one thing that I avoided in PD was actually ever referencing pitch at all,
Yeah,
musical pitch, right?
but you've got M to F there to do your
Yes.
translation.
Yep.
Yeah.
That's the one place where you get reference to our pitch system.
But it's also just a translator from linear to logarithmic.
Yeah, right.
That's the way.
Yeah, yeah. It's 440 times 2 raised to the power x minus 69 quantity over 12. You could have typed that out, but I decided to take pity on the poor composer and wrote an object.